We appreciate your time. Don't you want to learn mathematics the correct way? You need a foundation. Do not just be guessing at your numbers. Contact us today. Look us up on your Facebook at Fort Bend Tutoring.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today's lesson is going to be about subtracting rational expressions. Subtracting rational expressions, aka fractions. So let's dig in. All right. We have problem number 1 here. Now, keep in mind, ladies and gentlemen, that when you are subtracting rational expressions, and what is a rational expression, by the way? It's a fraction. So why do they call it a rational expression? Because the fraction has a variable in it. That's it. So every rule that you've been doing with fractions, you'll also be applying to rational expressions because they are fractions. Fracciones. Exactly. So here we are with number 1. And anytime you're adding and subtracting fractions, what must you have? A lowest common denominator, preferably a common denominator. That's what you want. So in problem number 1, I have 9 over 4x cubed minus 17 over 4x cubed. These two terms already have a common denominator. They have 4x cubed as the denominator. Therefore, all you have to do is subtract. Remember when you're subtracting like terms here? You're going to always keep the sign of the biggest number. So your biggest value here is 17, so the result will be a negative result. So let's go ahead and write that out. I'll end up with a negative, and the difference between 17 and 9 is going to be 8. So I'll end up with negative 8 over 4x cubed. But with any fraction, you need to simplify it. We got to reduce this. So if you'll notice here, my coefficients, the numbers 8 and 4, can be reduced by 4. So what will happen is this 4 gets canceled out to 1. This 8 gets canceled out to 2. So I'll end up with negative 2 over x cubed. And that's the result. Yeah. Got a big red box around that answer. There you go. There you go. There you go. I'm not going to be stingy with the answer. So here, I'm going to reduce, once again, the 8 and the 4 can both be reduced by 4 because you always want to simplify your rational expressions, aka fractions. So 4 went into itself once, 4 goes into 8 twice, and then you ended up with a negative 2 over x cubed. Once again, from the beginning, we had to guarantee that we had a common denominator, and we did. So since they already had a common denominator, all you had to do was subtract. In other words, combine the numerators together. A positive 9, a negative 17 combined to give you a negative 8 over your common denominator of 4x cubed, and then we simplified to get an answer in a red box. And that's it. All right, let's move on to the next one. Problem number 2. Problem number 2. Let's focus. All right. Problem number 2, we have x squared over x plus 5 minus 25 over x plus 5. Once again, we already have a common denominator. That's a good thing. So therefore, we can just combine the numerators together. So when I rewrite this, I'm just going to show that the numerators are going to be combined. So I'll rewrite this as x squared minus 25 all over x plus 5. All right, now you should recognize that your numerator is a difference of two squares. This x squared minus 25 can be factored, and that's exactly what you're going to do. You're going to factor the numerator, and that's going to give you a result of x plus 5 times x minus 5. And all of that is going to be over my common denominator, which is x plus 5. So I had this difference of two squares. I factored it into the following: x plus 5 times x minus 5. Once I have this, notice that we have a common factor in the numerator and the denominator. That means we can cancel it out. Recall that anything over itself other than 0 will equal to 1 when you're dividing. So this cancels out to 1. That cancels out to 1. So your end result is simply going to be x minus 5 over 1, which is just x minus 5. All right? And that's your answer. So let's recap. We had our initial problem, x squared over x plus 5 minus 25 over x plus 5. We already had a common denominator, which meant that we could combine our numerators together. So I rewrote our problem as x squared minus 25 over the common denominator of x plus 5. Noticing that our numerator is a difference of two squares, you can factor this out. So I end up with x plus 5 times x minus 5 all over x plus 5, and then because we had a common factor in the numerator and the denominator, you can cancel it out, and that's exactly what we did. That ends up giving us a result of x minus 5, and I like a red box around my answer, so that's what I did. All right, let's move on to the next one. Here in problem number 3, I have 11x minus 13 over 2x minus 3 minus 3x minus 1 over 2x minus 3. Yes, we still have a common denominator, and trust me, we will be getting to problems that don't have a common denominator, but this problem is important. The reason being is because when you combine the numerators here, you will need to end up distributing this negative. So let me show you exactly what I'm talking about. So this problem is important. All right, we'll have 11x minus 13 minus the quantity of 3x minus 1. See, what happens is that negative, this minus sign, needs to be distributed to everything in the second term's numerator. All right, it's still going to be over your common denominator of 2x minus 3, but we're going to take our time with this, all right? So let's take our time, make sure we're getting it right. The negative in front of the parentheses will need to be distributed. So I'm going to get my arrows popping. Exactly. Got my arrows popping because you know by now that I love the distributive property. So I'm distributing that negative there. I'm going to end up rewriting this as 11x minus 13 minus 3x plus 1. That's why it's important to distribute that negative, because it not only affects the 3x, but it also changes the sign of that negative 1 into a positive 1. All of this is going to be over 2x minus 3. From here, we'll end up combining our like terms in the numerator. So 11x minus 3x gives me 8x, and negative 13 plus 1 is going to give me a negative 12. All of this is going to be over 2x minus 3. Notice that in your numerator, you can factor out a 4. So let's do just that. So factoring out 4, I'll end up with 4 times 2x minus 3 all over my common denominator, which is that 2x minus 3. From here, what happens is, notice that I have a common factor in the numerator and the denominator. That 2x minus 3 will end up canceling out. So your end result, it will just be 4. And that's the answer. Done. So let's recap over this. We started out with 11x minus 13 over 2x minus 3 minus 3x minus 1 over 2x minus 3. We did have a common denominator, so we didn't have to worry about that, but I was warning you that when you have multiple terms in your other numerators, that you'll need to use parentheses and subtract, which gives you the chance to distribute the negative into the second set of parentheses. So I'm going to distribute that negative, and I'll end up rewriting it as 11x minus 13 minus 3x plus 1, all over the denominator of 2x minus 3. From there, we combined our like terms in the numerator. That gave us 8x minus 12 over 2x minus 3. And notice that in the numerator, we had 4 in common. So you factor out that 4. That gives you a result in the parentheses of 2x minus 3. And notice that that numerator and the denominator had a common factor. So we cancel them out. And you end up with your numerator 4 being over 1, which is just 4. So there you go. And a red box. Done. All right. Let's keep it moving. In our problem number 4 here, we have a over a minus b over b minus a. Notice that in this problem, ladies and gentlemen, that your denominators are similar, but they are not the same. In fact, what you should notice is that the denominator's terms, that positive a, that negative b, are actually reversed, or you can say the opposite in your second term's denominator. Instead of having a negative b, we have a positive b. Instead of having a positive a, you have a negative a. So let's do a couple of steps here in order to make these two denominators the exact same. All right, let's check it out. In our first step, what I'll do is I'm going to simply switch around in that second denominator. I'm going to switch around those terms. I'm going to rewrite this as negative a plus b. All right, so that's what I'm doing there. So all I did was I put that positive b as the second term in the denominator, and I wrote that negative a as the first term in the denominator. All right, then from there, in that second denominator, I'm going to factor out a negative. So I'm going to rewrite this as a over a minus b minus b over, and I'm going to factor out a negative. So I'm using parentheses, so this will be a negative a minus b inside the parentheses. So what happened in this second denominator, I factored out a negative, and factoring out a negative, or you could say negative 1, this leaves me with a minus b inside the parentheses. What you'll do next is that these two signs will be multiplying together. In other words, they'll combine to make a positive. Remember that a negative times a negative is a positive. So I'm going to rewrite my problem now as a over a minus b plus b over a minus b. All right, and so from here, I now have a common denominator. Since I have a common denominator, I can simply add the numerators together now. So this gives me a result of a plus b over a minus b. I want you to know, ladies and gentlemen, that since the numerator, that factor of a plus b, is not the exact same as the denominator, the a minus b, you cannot simplify anything else. In other words, I can't cancel out these a's and I cannot cancel out the b's. You cannot do anything further to simplify this problem unless all of the terms had something in common, and they don't. So therefore, this is your answer. So you'll keep it just the same as a plus b over a minus b, and that's it. That does it for problem number 4. In problem number 5, I have x over 3 minus the quantity of 4x minus 2 over 2x. So what I need to do first is get a common denominator. What I like to do is to focus on the coefficients first, the numbers in front of the variables. So I'm just looking at the 3 and the 2. So I know that the first number that 3 and 2 can go into evenly is 6. And keep in mind that you only had this variable x, so I'll need x in the denominator. So the lowest common denominator here is 6x. So I'm going to change both denominators to have 6x. All right, so just like that. So I have my framework. We'll call it that. So what you'll do next is compare the original denominator to your new one. We had to multiply 3 times 2x in order to get 6x. So I'm going to show that this was multiplied by 2x, and therefore I'll also need to multiply the numerator by 2x as well in order to have an equivalent fraction. So once again, those same concepts that you use for fractions, you'll also use for rational expressions. So you always have to have an equivalent fraction once you change that denominator. So 3 was multiplied by 2x to get 6x, and now x times 2x will give me a result of 2x squared. In our second denominator here, I had 2x, now I have 6x, so we had to multiply that by 3. So since 2x was multiplied by 3, this 4x minus 2 will also need to be multiplied by 3. So doing that, I'm going to take my time here and write this as 3 times 4x minus 2. I'm going to write it just like that, just showing the fact that I had to multiply this by 3 because my original denominator was multiplied by 3. At this point, I'm going to combine, the numerators together. I'm going to rewrite it. So rewriting the numerators, I'll end up with 2x squared minus 3 times the quantity of 4x minus 2, all over the denominator of 6x. From there, I'll now distribute this negative 3 inside the parentheses. So I got my arrows popping. So I'll end up with 2x squared minus 12x plus 6 all over 6x. All right. Notice that every term in your numerator can be divided by 2, or at least you can say you can factor out a 2, and that's exactly what we'll do. So let's go ahead and take this on to the next page here. Now let's continue working out this problem. All right, so there it is. Cool. So what we're going to do is we're going to factor out a 2. This leaves us with x squared minus 6x plus 3 all over 6x. And if you check out your trinomial here, there aren't going to be two numbers that'll multiply to give you 3 and add to give you 6. Therefore, you cannot factor this trinomial, okay? So, keeping that in mind, I'm going to simplify. I know that 2 will go into itself once, and 2 will go into 6 3 times. So, I'll end up with a result that's x squared minus 6x plus 3 all over 3x, and this is my answer. I can't reduce this any further. This is going to be your result. X squared minus 6x plus 3 all over 3x. Done. All right. Let's check out the next problem. In problem number 6, I have 3 over x squared minus 5x plus 6 minus 2 over x squared minus 4x plus 4. The first thing you want to do is recognize that you do not have a common denominator. They're different. So you should go ahead and try to factor as much as possible in each denominator so we can notice the different factors that we're dealing with. This first trinomial, you'll end up with x minus 3 times x minus 2. In other words, the negative 3 and the negative 2, those were two numbers that will multiply to give you positive 6 and add to give you negative 5. So that's what we have. If you factor out the second term's denominator, you'll have x minus 2 times x minus 2. All right. Now that I have those two denominators factored out, I can come up with the lowest common denominator. So the LCD, ladies and gentlemen, that I'll need is x minus 3. I'll need an x minus 2. And since this second denominator had two of the exact same factor, I'll need two of those as well. All right. So that means that my common denominator is going to be x minus 3 times x minus 2 times x minus 2. All right, so that's going to be my framework here. Here it is. All right, so x minus 3 times x minus 2 times x minus 2 is the lowest common denominator, or if you want to be a little fancy, you can write it as x minus 3 times x minus 2 squared. Yep, you can. But I prefer to leave it written out in expanded form because I use that to compare the two denominators. So that's why I leave it expanded and not written with an exponent. All right, so comparing the first term's denominator to my new lowest common denominator here, I had to multiply this denominator by x minus 2, right? So whatever I had to multiply the original term's denominator by is what I'll need to multiply the numerator by in order to make an equivalent fraction. So since I did not already have two of these x minus 2's, only had one, I'll need to multiply the numerator by x minus 2. So that's what I have now. Then, what's the difference between the second term's denominator and our LCD here? That's right, it's the x minus 3. So I'll need to multiply 2 times this x minus 3. All right, so that's what I'm looking at right now. All right, good stuff. Continuing on to the next step. What I'll do is I'm going to combine the numerators together. And when I mean combine the numerators, I'm just going to do just that. I'm not going to go ahead and start distributing. I'm going to take this one step at a time. So I'll have 3 times the quantity of x minus 2 minus 2 times the quantity of x minus 3 all over my LCD, which is x minus 3 times x minus 2 times x minus 2. All right, and that's what I have thus far. Now I will go ahead and distribute. So I have my arrows popping here. All right, so this will be negative 2 distributed in there. All right, doing my favorite property, the distributive property. And once that's done, we will move on to the next page. So here I'm going to say 3 times x is 3x. 3 times negative 2 is negative 6. Negative 2 times x is negative 2x. And negative 2 times negative 3 gives me a positive 6. All of this is going to be over my common denominator, which is x minus 3 times x minus 2 times x minus 2. All right, and now that we've run out of room here, we're going to take this to the next page. Let's go ahead and take this to the next page. All right, so that's what we got. Let's copy that and move on. All right. Okay, so here we are. Now that we have distributed, our next step is to combine any like terms that we may have in the numerator. And we do have like terms. So I have 3x minus 2x gives me x. All right. And what happens to this negative 6 and the positive 6? Exactly. They cancel out. So since they cancel out, I'll have x over my denominator, which is x minus 3 times x minus 2 times x minus 2, and that could be submitted as an answer, but most likely your teacher will want you to have this fully simplified, so it's now that I'll write that x minus 2 to the second power. So I'm going to rewrite it as x over x minus 3 times x minus 2 squared, and this is going to be my result. Done. All right, so that's the answer. Good stuff. All right, let's check out what we have next. All right, in our next problem, we have problem number 7, 5x over x squared plus xy minus 2y squared minus 3x over x squared plus 5xy minus 6y squared. All right, so notice that in our denominators here, we actually have two variables in our trinomials. So you still want to notice, 1, that you don't have the same denominator, and 2, you'll need to factor so that we can come up with our lowest common denominator. So let's do just that. So factoring the first denominator, we'll end up with x plus 2y times x minus y. All right, so that'll be the factorization of that. So factoring the second term's denominator, you'll end up with x plus 6y times x minus y. All right, so that's what we have after we factor out those denominators there. Okay, so we need to come up with our lowest common denominator using these factors. So the lowest common denominator, I'll need an x plus 2y. I'll also need an x minus y. And I'll also need an x plus 6y. So this is going to be my denominator right there. All right, and let's go ahead and set up that framework. So I'll need to write it again. And this is going to be obviously smaller because I didn't leave myself much room, did I? All right, so, oh, that's just lovely. That's just lovely, isn't it? Look at that. That's just beautiful. So we have the denominator x plus 2y times x minus y times x plus 6y, and that's going to be the same for both denominators. That's our lowest common denominator. Remember, we compare the denominators. Whatever you did not have in your original denominator, you'll need to multiply your numerator by. So I'll need to multiply 5x by what I did not have in my original term's denominator. So I'm multiplying 5x times this x plus 6y. I did not have that as a factor of my original denominator. So it'll be 5x times x plus 6y. That goes right there. Then, looking at the second denominator, I did have an x plus 6y. I do have x minus y, but I don't have an x plus 2y. So I'll be multiplying 3x times this x plus 2y here. And that's what I have thus far. Then my next step always is just to simply combine my numerators together. I don't prefer to distribute now because a lot of times you can make some itty-bitty mistakes that'll give you a wrong answer. So take your time, combine your numerators. Don't do 2 or 3 steps all at once because that increases your chances of making a mistake. All right, so here rewriting this, I'll have 5x times x plus 6y minus 3x times x plus 2y all over my lowest common denominator, which is x plus 2y times x minus y times x plus 6y. All right, and that's what I have thus far. Okay, so let's go ahead and copy this and take this on to the next page. All right. Hey, act right. There we go. So continuing on, problem number 7. All right, there we go. My next step is going to be to distribute. So I'm going to distribute the 5x. I got my arrows popping. I know you're waiting on it. I knew you were waiting on it. There you go. And I'm going to distribute this negative 3x into the second set of parentheses. So once again, got my arrows popping. There you go. So 5x times x gives me 5x squared. 5x times 6y is going to give me a positive 30xy. Notice how I'm writing my variables in alphabetical order. That's going to help me identify any like terms later on. Then I have negative 3x times x. This gives me negative 3x squared. I also have negative 3x times 2y. This gives me negative 6xy. All of this is going to be over the common denominator, which is going to be x plus 2y times x minus y times x plus 6y. All right, so what do we do now? Exactly, we combine our like terms in the numerator. So that's exactly what I'll do. I have 5x squared minus 3x squared. That gives me a result of 2x squared. Then I'm going to combine this 30xy minus the 6xy, and that gives me a positive 24xy. All right. All of this is going to be over the common denominator, which is x plus 2y times x minus y times x plus 6y. All right, like so. Now, you can factor out 2x out of the numerator. That'll leave you with x plus 12y in parentheses. It cannot be simplified any further because it won't cancel out with anything in the denominator. So this is going to be your answer. All right. So I'm going to show you that this is my answer. It can't be simplified. However, I'll go ahead and show you what I was talking about if you were to factor out the 12x and why you can leave this as your result. If you were to factor out the 2x, you would have 2x times x plus 12y. All of this is going to be over your common denominator, which is going to be x plus 2y times x minus y times x plus 6y. Notice that none of these factors in the numerator and the denominator are the same, so you cannot cancel out anything. So if you are not certain, you do want to factor it out to make sure that you can't cancel out anything if you don't foresee that. But if you can notice here, if you factor out the 2x and you'll be left with x plus 12y, you did not have a denominator, a factor in the denominator rather, that was identical to this x plus 12y, or that you could simplify with this 2x. So therefore, that's why we leave the previous step as our answer. Some teachers will accept this as your answer, and it's not a problem using this as your answer. It's just that it's unnecessary to factor it out in this case. But once again, if you're uncertain, factor. Definitely factor to make sure it won't cancel out. So that's going to do it for our lesson today, ladies and gentlemen. So I hope you appreciated everything that we offered up today in subtracting rational expressions. And as always, please like it and subscribe to the channel Fort Bend Tutoring. And if you find yourself on Facebook, go ahead and give us a like on our Facebook page, Fort Bend Tutoring. This is Mr. Witt saying peace.
Learning mathematics is very, very difficult to many people, second only to learning how to speak English. Do you have difficulty? Don't be embarrassed, since a lot of people don't know what they're doing when they get up there and do their mathematics.